Hello, everybody. Welcome back. It's Brian and Mr. Betcher for Breaking Down Security.
Hello.
We are here to talk about another tool, very important, very nice tool called Tcpdump.
Tcpdump. Yes.
Yes, it is probably from one of the first, I would imagine, tools. It's what came out in 1987.
Wow. Okay.
Yep. And it was created by three gentlemen who, I guess, needed to monitor network traffic or what have you.
They didn't use it for security at that time, did they?
I would imagine a lot of things back in 1987 were not security driven.
Okay.
You know?
Not many things are.
Yeah. Well, at least back in the day. I mean, security for the internet or networks, or Unix in this case, was bolted on after the fact in many cases. I mean, when the first Unixes started out, they didn't even have owner and group permissions. It was just like, everyone can touch everything. And then they realized, we probably need to, have a multi-user environment. So
You're old.
I know.
Unix and stuff.
Yeah.
Yeah, I find that a lot of tools that security pros use aren't really security tools at all. You've got your log correlation engines as one example.
Yeah.
I mean, they're not really advertised as security tools, but
Nope.
they're very good.
Yeah.
For that purpose.
Yep. So Tcpdump, I guess, had a bit of a rocky history. They had everybody took it and did what they wanted to with it. They put their own patches in. They put it in their own Unixes or own Linuxes, and you had 15, 20 different versions out there. You had one that would, capture on, do specific things, or another one wouldn't capture, have the same logic where you couldn't do limit filters. The filters might be different, or the language might be different on how to do the filtering. So there were two guys in 1999 created Tcpdump.org. That would be Michael Richardson and Bill Fenner. They created that to kind of unite the Tcpdump versions into what we have today, I think, pretty much. I don't know of any Tcpdump that does anything different unless it's a BSD derivative where Linux does some things that the BSD version doesn't. Which is good because, if we'd had as many Linuxes as we did back then today, there'd be like 500 Linuxes. There could be 500 different versions of Tcpdump, and you'd need to know the intricacies of each one, if you had to use more than 5 different versions of Linux. So it's still actively developed.
Yes, it is. I can't imagine why, but I guess new functionality is required of it, and they just add that on. But I guess TCP hasn't really changed that much.
No,
recently.
No, I don't think the Tcpdump has. But I mean,
the protocol
hasn't changed, or IP, or it does more than just TCP and IP. It will look for IPv6 now. It'll look for, you can have it do filters for different protocols like IPv6 or DHCP or ICMP. There's a number of different things. So like September 2nd, as a matter of fact, they came out with a new version. They're fixing configurations. They're adding options for the number signs. They're still adding a bunch of functionality. So
they're tweaking
it, yeah.
Trying to make it better.
Even bug fixes, fixing crashes on Spark architecture as of January 15th. So you can go and look at the change log for that. So why would a security person use Tcpdump? We're overlooking that there is in fact a more popular version called Wireshark. But today we're just going to talk about Tcpdump because
isn't Wireshark more popular?
I would say that the fact that it has a GUI makes it more popular. People don't necessarily, I wouldn't say necessarily hate the command line, but they, people who are new to security or to Linux probably might be a little afraid of the command line. I've always said it's more powerful, and even Wireshark has a console version called T-Shark. I think it's T-Shark that you can use the command line on as well. So, but I find TCPdump to be easier with regard to filtering, which we're going to explain some filters later on.
So TCPdump is a protocol analyzer.
Yeah.
Without the program analyzing the data and putting it into a form you can understand, all you would see is a stream of bytes.
That's right.
Across, right?
Yeah, and it does break it down. You can capture from just the headers or the source and destination information all the way up to a full packet, which can be quite large in many cases. Let's see. So how does TCPdump work with your computer? So if you've got a Windows box or Linux box, how does it capture the data?
Well, it puts whatever interface you want into promiscuous mode. That's one of those words I can't say. I don't know. Every time I try, it just comes out wrong. So then it'll read everything, and if you want to display it, that comes into that interface. So if you have a hub, if you're connected to a hub, it'll capture all traffic going through that hub. If you have a switch, well, the nature of the switch is to only send traffic to that particular device, so you'll only get your traffic into that interface. So you'd have to configure a span port or something.
Yeah, that's definitely a nice delineation. If you're going to be troubleshooting, say, a host on the network, and you're using a switch, you're either going to have to run TCPdump on the host in question or set up a span port like you mentioned.
Yep, or do a tap, something to that effect.
Or do a tap, right.
Yep.
So did we mention promiscuous mode in our wireless podcast?
I don't know. Did you put it in your video?
I want to say I did.
I'd like to think
one of the videos. Yeah, I'd like to think I did. So you might hear promiscuous mode when you're talking about wireless interface as well, and there's a difference between wireless promiscuous mode and what they call monitor mode on wireless. You can run TCPdump on a wireless interface as well, and when you put a wireless interface in promiscuous mode, what it does is it will grab all of the packets regardless of if it's on an AP or not, if it's authenticated to an AP. So it basically is in huge listening mode. Monitor mode, which is what you hear in wireless interfaces, will only capture packets after you've authenticated to an AP. So promiscuous mode is what you want on a wireless interface.
Right.
On a wired interface, you don't have a monitor mode. There is no monitor mode for wired interfaces. You only have promiscuous mode. So you might have heard that, in the wireless section or on wireless interfaces. And when you run TCPdump on a wireless interface, you want to make sure that you have promiscuous mode, not necessarily monitor mode. So,
all right.
Yeah. So the powerful thing about TCPdump, much like Wireshark, is the way you can filter.
Well, what's the question was, what does a security person need with TCP?
Oh, right. That's right.
So you kind of skipped over that.
I'm sorry. Yeah, we're trying something new. We actually have a presentation kind of thing where we're looking at slides and understanding why we need these things. So, all right. So why does security person need TCPdump or a packet? Let's back it up even further. Why would they need a packet analyzer or network analyzer?
Well, the way I used it before was for network troubleshooting when I was like a sysadmin type. Application couldn't get a connection for some reason, and so I'd run TCPdump on the endpoint, and network engineers would run a similar tool on their network devices, and we'd kind of follow the chain and see where it's going. So it's a good troubleshooting tool. that you could use. Now, a security practitioner would use it, to do forensics. That's the first thing that comes to mind. If you've got a particular piece of malware that you're trying to inspect, you can see, where your connections are trying to go in and out.
Mm-hmm.
That's another reason.
Yeah. Yeah, if you're actively watching somebody get into your network, you can, if you found that this host is being used as a pivot point, you can find out where the person is using this host to pivot to, by monitoring the outgoing traffic in this case. If data is being exfiltrated out of your network, you can run Tcpdump or a network analyzer on your egress to find out, and you can actually, with Tcpdump, which is nice, you'll take a packet and it's in a hex code format. Tcpdump will convert it or encode it, as we've talked in previous podcasts, encoding from one version from hex to ASCII, so you can actually see the plain text going across the wire. So you can see if it's, personally identifying information, PII, if it's medical records, PCI data for PAN,
Right.
It will decode it for you and show you what is actually being sent across the wire.
Right. It'll decode it for you. And another thing you can do is it'd be a quick and dirty notification for something that, let's say you just implemented a new application and you don't have any monitoring on it yet. You can run a TCPdump command line in the background and say, okay, if there's any data going to any other computer other than these IPs, I want to, a printout of that. I want to put it to a log. I want to, and you can set up some sort of an alert. So it is a quick way to do some monitoring as well.
Sure. Yeah, and, you were mentioning, I just thought of something just now. You've got an application. It's older than dirt, and there's no real documentation for it, so you don't know how it functions. You know that it does a function on the network that is important, but you don't know what ports it runs on, what data is being sent or how it's being sent. If you're doing applications, especially in like mobile applications, and you want to know what your weather, like you've got a weather app on your phone. If you're doing application mobile testing for applications, you may run TCPdump on a switch or on the host itself. Like my Android phone has a TCPdump or a Wireshark in this case analyzer. I can watch packets going across the network having to do with that app, and then I can find out, okay, this app sends my contacts list. It sends my, it sends it all out on this port. And this shady app that I have is actually sending data to not only, my Google Drive, but it's also sending it to, 1.2.3, which is in, China or something. So you can use it for testing, for application testing as well.
Exactly. I was at a talk. A senior SANS instructor gave a talk, and he tested a few mobile apps, and he installed 10 apps on a brand new or a new install of an iPhone and an Android, and just by turning the phone on, he saw 23,000 requests go out just by turning the phone on. Because of those
this was
apps.
using and this was using a packet analyzer like TCPdump.
I have no doubt that he just used TCPdump to analyze the data going across the wire, or, wireless.
Yeah.
Yep. So you can test new apps that, let's say you've got a request in your company that employees want to use a certain app, like it's going to the cloud or whatever. You can test that app out to see what it's actually doing, because I would not be surprised if it sends data to advertising companies or whatever.
Yeah. You want to make sure that if you are running applications or you've built an application, that it is only sending what is necessary and it's not sending things that will get you or your company or in trouble, especially if you're running a mobile, you're running enterprise mobile system. You want to make sure that if John is putting fancy birds instead of Angry Birds on his a fancy knockoff of a well-known I'm running Fancy Birds. It's called Angry Birds, John. You should be using that one. Oh, this is a Chinese knockoff. It's cool. It's awesome. Yeah, well, Chinese knockoff is sending company data and company emails to China so that competitors can have an edge on the competition. So,
well, we love our Chinese listeners, though.
Yes, all of them, and not everybody in China is a bad guy. We love you, and everybody in Mongolia.
It's a slip of the tongue. Yeah.
Yes, yeah, merely slip of the tongue. So, what makes TCPdump powerful, I think, is the filtering. Not just, being able to watch all the traffic, because, like we've said in our logging podcast and Michael Goff, you want to only pull what is useful to you. You don't want to pull the fact that
you don't want to get everything.
You don't want to get everything. You only want to get what is necessary. So you want to filter out, in this case,
the hay.
What is
You want to filter
normal,
out the hay, the normal.
Filter out and you've got the needles at the end, like you say. So TCPdump has the ability to filter, of course, from IP addresses. So you can filter by hosts. You can filter by source or destination. So if traffic is coming in, you can filter from a specific source, or you can filter to a certain destination. So if the host you're on is sending packets out to hundreds of different places, but you only need one or two, you can say, I want to filter from on this interface from a destination and this IP address. And we're going to put some examples of command line arguments you can use for TCPdump in the show notes.
Yeah, so it's pretty flexible. You can filter stuff out. You can filter stuff in by port, by host. It does DNS. You can filter out DNS names. So if you're more along the lines of an IP, network engineering type, you like IPs instead of names, you can filter that out. All kinds of stuff. It's really it's got a lot of good stuff in it, and the man page is pretty good as well. It's got a lot of good information there. Yep,
and you can one of the things you want to look at is if your box has multiple interfaces, and you can actually have it capture on every interface. So if you have a server with 25 interfaces, it will capture, and it can capture all 25 interfaces, including loopback. So if you want to make sure that you're only capturing the proper port, because you may be capturing traffic you don't need. Again, when you're filtering things, you may be capturing traffic you don't need. So one of the first things you want to do is understand the -I, which lets you set a specific interface for the for capturing on a specific interface. You can also capture specific number of packets. So if you know that, let's say, the application starts sending bad traffic in the first 500 packets that it sends, you can say, I only want to capture the first 500 packets of, when it first starts capturing. Or, that's pretty powerful, because you don't want to just allow capturing all day.
In some cases, yeah.
In some cases. And, it cuts down on the amount of analysis you've got to do if you only have to analyze 500 instead of 5,000 packets.
Or if you want to fine-tune your capture, you can run a capture of everything, save it, and then use TCPdump to open the file again and filter on different things so you can, nail down what you really need.
Yeah, you can replay. And I think once you do the replay, you can also make changes to the PCAP at that time.
Yeah, I guess you can load it and then save it again after you filter.
Yeah. Yep. You can actually capture only TCP packets. So if you're running a time server and you're going to get a lot of UDP, or you're running a box that does a Pixie boot of a system, you can look to see if there's any TCP traffic coming from that server. Or If you are running a web server and you're noticing UDP packets coming from it and there shouldn't be any, you can capture only the UDP traffic for analyzation later. That can be important. Let's see.
You can run those outputs into a log correlation engine as well.
That's right. I have a link here to a SANS paper where a gentleman had used Splunk and a packet capture file. So he, let me see, his name is, and actually this is pretty recent. This is May 18th, 2014. I just found this as we were talking just now. So he did it. It's in the InfoSec reading room at SANS. So I will post a link to that. You can take Splunk, or you can take a log correlation engine and take a PCAP file and analyze it that way if you want to do some self-analyze, without having to. His name was Alexandria Texiera. So there you go. Good on you, Alexandra. Yeah. Maybe. I just ruined the name. I'm not good.
You're not good with names. You need to note to self, practice before
practice
our podcast.
Names. Well, literally, I just scrolled down to try to find the names.
Nice multitasking, though.
I know, right? So, you can capture interfaces. You can do replays on that. You can even limit the amount of information you get in the capture. So if you don't need the whole packet and you just need to know the IP address the host is coming from, you can capture only the headers, or you can capture just the fact that it's getting traffic from an IP like that. And you can even do greps, looking for specific words in the stream. So you can do a TCP dump, dump the entire packet and grep for, say...
credit card data?
Well, you can grep for credit card data, but, you have to make sure you have a valid credit card if you're looking for that specific credit card. But you could say grep for Bob, for instance. And if a packet goes through and it says Bob, so if you've got a health record or something and a guy named Bob shows up and he's a patient at the hospital or has been a patient at a hospital, that will say, okay, yeah, there's a packet, and it shows Bob's name in the packet. So then you'll have packet data, healthcare data going across. Or
that's cool. And here's something interesting. You can, if you provided a key, it'll actually decrypt your messages as well.
Oh, it'll decrypt SSL traffic. Yeah. Well, that would be good if you did the capture and then did the replay later, because then you could supply the SSL key for that.
Yep.
Now, do you need now I don't know this because I'm asking this question right now. Which SSL key do you need? Do you need the server key? So if you're going to, the user, if you're capturing your own SSL web traffic, can you use the server key, or is there another key that you use for it?
Oh, I don't know the answer to that.
Okay, I'm sorry.
Yeah, yep. Shouldn't have brought up the encryption part.
It's okay. Let's see. SSL Tcpdump. Using my Google foo right here. Okay, so if you go to rtfm.com, and I will definitely have a link to this in the show notes as well. There's actually an application called SSL Dump, and you can dump the SSL traffic on your network. So it's a protocol analyzer as well. So there you go. There's another one if you're doing SSL traffic. I assume it uses its own protocol analysis. It looks very much TCP dumpish. The filters on it are DST host, and then you put the IP host. So I'm assuming it's very much TCP dump like. But it is a fork, I believe, of TCPdump.
So why is TCPdump better than other tools, similar tools?
I don't really have a preference. I say I do, but I find that TCPdump is often on a lot more boxes. It's like the VI and Emacs thing. If you get on a Linux box, you can almost guarantee that VI or Vim is going to be on the box. Maybe not necessarily other ones like Nano or Emacs. If you get on a Linux box, TCPdump is usually installed on the box.
Okay, so it's readily available.
Yeah, there's less resource requirements for it. You don't have the big GUI to have to deal with additional issues with vulnerabilities that might pop up. It's less resource intensive, so you don't have to. You can run it on a lower platform level, so you could run on, say, a slower processor than you could.
There's less overhead than the graphical ones.
Yeah, you don't have to have a graphic, and you don't have to have a monitor. You can run this on a headless box.
Yeah.
So that's another reason I like Tcpdump. Now Wireshark does have a console version. I've never actually used it because when I use Wireshark, it's usually on a Windows box. I rarely use Wireshark on say Kali or something. I'm always using Tcpdump. And the good thing is you can take your PCAP file, and it pretty much runs anywhere. You can take your PCAP file and put it into Wireshark if you wanted to analyze it further later. As a matter of fact, I think when we were in our SANS course, it was suggested by the instructor that you take your PCAP file from Tcpdump, because there have been attacks on Wireshark while you're doing the capture where the filter, if you're filtering, can cause issues, security issues wise, whether it be a denial of service or it crashes the Wireshark to begin with. So attacks that happen on Wireshark don't necessarily translate to Tcpdump, and vice versa.
So there's attacks to Tcpdump as well. I've heard of the Wireshark vulnerabilities, but not any with Tcpdump that I'm aware.
Yeah, I'm not sure if there have been any CVEs or anything put out for.
So basically, the gist of it is, don't run a capture with Wireshark. Run your capture with Tcpdump, and then you can analyze that capture with Wireshark if you want.
Yeah, there have been actual, as of about a year ago, they had a denial of service attack on Wireshark on their website. So, if you're running that was the website. I'm gonna have to.
So, I'll be getting into this in the near future. It's the next book I'm going to read when I finish my current one is this one right here, TCP/IP Illustrated Volume 1. So,
oh wow!
This book was recommended to me by a senior SANS instructor. You can never guess who it was. But he said it was one of the best books for his career that he's ever read. And, it really gives you an insight into what's going on under the covers. As in reference to, security, network, traffic, and basic computer-to-computer communication.
Yeah.
So, that'd be a good one as a foundation to understand, what's going on.
You're going to have to send me the link for that so that we can put it on there. I actually have the No Starch Press practical packet analysis.
I've heard of that one.
It's pretty, it's pretty Wireshark intensive, but the concepts are still the same with regard to understanding protocol dissection and stuff. So I was looking for CVEs for Tcpdump. According to CVE details, there hasn't been a vulnerability in Tcpdump since 2005.
Okay.
But if you go to Wireshark, they're actually nice enough to put the security advisories on their website. So they have issues with sniffer file parser crashing. That was as of 1.12.1. They have an RTSP dissector crash. So it looks like it's not Wireshark that's the problem. It's the filters that people create for Wireshark. Because they create special filters for various traffics. So you get a bunch of MPEG file parser buffer overflows, NFS dissector crashes. You've got a lot of stuff, and that's just in 2014. They've had 20 vulnerabilities this year alone for vulnerabilities. So that's why it's probably better if you did capture it in a Tcpdump or another like SSL dump in this case. We just found that one. And then run it in Wireshark if you wanted to have a nicer graphical interface.
Yep. Graphical interface is easier to use, or
sure.
A lot of people visual
Yeah, very visual. So we mentioned on ways of setting up TCPdump to work on the network. There are really only three, and it's kind of like the IDS stuff. And we were talking before the podcast about how TCPdump is kind of like how an IDS would gather traffic. It has to, have the ability to listen to the network traffic,
Yep.
and based on filters that it has, or snort rules, or sourcefire rules, or bro IDS rules, it looks at specific parts of the packet and go, oh, okay, that's a vulnerability because it XYZ, So there's really three ways of setting up your network if you're going to do a capture with TCPdump or Wireshark. There's the tap, which I'm assuming a tap in this case is a hub, or
it's inline. So
it's inline?
Yeah. It's
in between. Okay.
Mm-hmm. So you
So it
tap
can
a
be
specific
what, a
line,
host.
and it just listens to everything on that particular line.
Yeah, and it can be a hub or a host. They have gigabit hubs that you can use. Most of them are 10100, and they have to be a certain type. They can't be like a switch hub or something like that, like a Netgear. You can't just go get a Netgear POS switch.
Yeah.
To run that. The other one is you can run it on the host, but that's like another type of inline type of listening because you're just a little bit closer to the host in this case.
Yeah, I suppose so.
And actually you can, if you do a tap instead of like on the host capture, you will actually disrupt the traffic. So if somebody is actively exfiltrating data to you, maybe disruption of the traffic to set your tap up is not going to be a good thing.
Yeah, it depends on what you want to do with it, right?
Yeah.
I guess you could consider an IPS a tap. I mean, it's in line, obviously. It's not just listening or mirroring the traffic.
Yeah. So I would imagine the least disruptive, if not actually running it on the host in question, would be to do a port mirror. So if you can get your network weasels on, the phone call with you, they can go to the nearest router or switch and set up a port mirror. So you have let's say you have an 8-port switch that's managed by Cisco or Juniper. You can say, okay, I want traffic coming in on port 1 to also be replicated on port 2. Just like an IDS. So that port 2, all you got to do is plug into port 2, start up your sniffer, start up your IDS or whatever, and you're getting the same traffic as the original host.
Yep. Or you can it's flexible. You can say I want to hook up to port 2 and sniff all traffic from 3 through 8 or whatever.
Yep. Yeah, you got to have a big enough pipe for that though. Yeah, you can't 3 or if you're trying 5 100 megabit connections trying to send it over one 100 megabit connection, the math doesn't add up. I was just thinking, one of the things we learned about in our ethical hacking course we took about a year ago, you could do ARP spoofing on a host on the network and make somebody believe that is actually the host in question. And if you did it for often enough, you could actually pull down traffic too, wouldn't you? You could do ARP spoofing.
I'm not sure. Pull down traffic. What do you mean by pull down traffic?
Well, instead of doing a port mirror or a tap, you've got host A, which has a MAC address of blah, which advertises itself on the network with the MAC address of blah. You've got host B, which is the box you want to record host A's traffic from.
Yeah.
You have host B say, hey, look, I'm MAC address A from host A now too. And the switch will say, oh, I see 2 on the network. I'm going to go ahead and send that traffic to both of them.
Yeah, maybe.
I am thinking that is how ARP spoofing works. According to our good friends over at Wikipedia, it's a technique where they send fake ARP requests. It's to associate the attacker's MAC with an IP address of another host, causing any traffic meant for that IP address to be sent to that attacker instead. So that could be another way you could actually do your man in the middle, or your, if you're trying to capture traffic for that.
Yeah, it is.
You can intercept frames.
It is for a man-in-the-middle attack. Yeah, and well, I guess so. I mean, you could use it for, capturing traffic.
Yeah. I mean, it would be very destructive, and the attacker would most definitely know that, hey, I'm not getting any more traffic from that guy anymore. And if you don't keep it up, then all of a sudden it will revert back to the original host. So, but that is another way you could technically capture traffic coming into a host, maybe, instead of going out, I would imagine. But
yeah.
Yeah. If you could actually get the host of the bad machine, if the bad machine was on your network connecting to other hosts on your network, you could do an ARP spoof so that the bad host would send you the traffic instead of the host that it was expecting.
Yeah, possibly.
Yeah. So, that's something we may want to talk about in the future, about ARP spoofing and some of the attacks you can do on a network. That would be a good idea.
Yeah, that's a good topic. Yeah.
All right. So, in closing, Tcpdump good. Protocol analyzing for security, very good. If you're using it for malware detection or application testing, that's always a good thing.
Yeah.
You can also be destructive with it too. You could, So.
Yeah, definitely recommend learning TCP/IP protocol and learning how to use tools like Wireshark and Tcpdump.
Yep.
Definitely.
Yep. So I guess that was it for this week with regards to TCPdump. We're on the internet. We have quite a bit of a network. We just surpassed 4,000 users on our Facebook fan page. Thank you to everybody who follows us on Facebook. I have a Twitter handle at Brian Brake. That's Bryan, and then like on a car, Brake, all one word. Mr. Betcher has one. I've been trying to do a follow Friday with him quite a bit to see if other people will start following him. It's Betcher Pwned. That's with a P, WNED. We're on LinkedIn. If you want to link into us, I guess that's cool too. I'm on Google+. BreakingSecurity.com. Tell your friends. We like having listeners. We like having feedback. So please feel free to send us feedback at our Google mail address, bds.podcast@gmail.com. All right, everybody. That was it for this week. You take care, and we'll see you again next time.
Bye-bye.